Hi everyone, my name is Cesar Nelas, and now I'm going to start explaining about the first themes of the statistical methods class. First of all, I want to say thanks to our professors um, for explaining all these themes and all these methodologies, so we can explain it to you. For this video, I'm going to start talking about for the base concept, starting by why is important the statistical methods and what are the ways to do this kind of analysis. So we're going to start talking about why are important. An incredible question. Well, first of all, we want to know three things. Number one, we need to organize our data. Organizing data. Statistics is for that. We need to organize our data to know what is going to be the next path, the next step we are going to do. Starting by organizing our data, we are going to see what is the tendency of the results, or what is going to be the problems, or where are the the product of all our data. The second point is about summarizing our data. And the third one is going to be to create a conclusion. And why is it important to say that we want to make a conclusion? A conclusion is going to be the result of all our experimentation with this data, starting with the conclusion that based on the information provided. This is one important thing. If we know what are we going to do with that, if we organize our data, then we summarize it, and then we create a conclusion, we are going to know what is the tendency of the data, or what is the things that we need to do with that data. So the important thing is, like, we need to create a precise way of measuring. This is because we need to know how reliable is going to be our decision. And this is so important because we are engineers. We need to know about our numbers, and we need to explain why we make that decision. And statistics is a very important thing to know. If we only have like a response of our analysis of our study. So that's now we're going to jump to our basic concepts. Basic concepts. Starting with population. Like the name, the population is all the, let's say example, all the people, all the microbial, all the things in a, all the atoms on a material, all the people on a country, all the animals on a zoo, something like that. It's like the population, like the people that live there, that this life is there. So this population are going to be the subjects, of investigation. And doing this, and with an example is like the population of a zoo. We have a lot of animals there, but they have different characteristics. So the population of the zoo, it becomes to be animals. So this is all the population in the zoo. Also, there are humans, but we need to make something to denotate that people, denotate that population, and that's a census. Census is we need information of our population, so we made a census to know the information of all the population. But if we're talking of a big population, it's not the same the population of animals in the San Diego Zoo and the population of animals on the, the Monterey Zoo. So we need to make a sample of it. The sample use a part of the population. So of all the population, we make a little circle of all the population, so we can characterize it. Then we need to measure something. So that's our variables. How many times they eat, how many times they go to the bathroom, how many times they breathe, how many times they make a sound, how many times they need to take a sip of water. So this is the are the variables, the things that change, and they change between the sample and between the kind of animal that we are going to study. It could be, and the studies could be from one variable. This is the easy one. We call univariable. It could be for all the sample. We only need to know variable. Like we need to know how many times they sip water. They take a sip of water. It could be two variables. It's going to call b variable. And if it's more than two, 3 points, two variables, it's going to be a multivariable. So we can do this kind of studies by saying which kind of variable we need to know. And so we need an answer, and that's the answer that we want to know, the variable. And this changes between the population or the sample or the census, and it could be then that's the answer that we need to know. Then we can say the variables could be numerical or categorical. And it could be numerical, like how many eyes, the animals that have 2 eyes, 3 eyes, 4 eyes, I don't know. Or categorical, it could be like mammals, or it could be 4 legs, or it could be or 4 legs. I'm sorry, 4 legs could be a numerical, or categorical could be mammals, or could be um, from a from a from a different from a different ecosystem or different part of the world. Then we have methodologies. There are two kinds. The first one is the descriptive methodology. It could be the first one that is summarize. We need to summarize the data to know an answer. And the second one is a visual representation with graphics. Representation with graphics and all kind of stuff. Then we have the inferential statistics. And here we need to draw conclusions. So the big difference here is like in this one, we arrange the data, we make possible iteration between them, and we make a visual representation like graphs. We need to know all the data, how the data arranged. And then the inferential statistic, we need to infer about what is going on in this graph. And then we infer the data, and then we draw a conclusion. So we now know where we're going to do, but we need to take a sample, and we need to have a good sample of what we're going to do. There's two kinds of samples. The first one is a simple random sample. Like the name says, for every part of the population, they have the same probability. For being choose. Let's say that using the example of the zoo, if a population in a zoo, it's 100 animals, these 100 animals have the same probability to be choose. So they have 1/100 chances for being chosen. Then we have the second one, that is the stratified, stratified sampling. Using simple random sample is not a bad thing, but we need to make something that is a characteristic that could be for englobing the same characteristics. So we make a stratified sampling to divide the population depending on a characteristic. The population, I'm sorry. The population depending on a common characteristic. So of these 100 animals, we can say that all the mammals are going to be on a sample. All the vegetarians one are going to be in another sample, and all the carnivore are going to be in another sample. So this is how we're going to divide our sample. So for 100, for a total, we have 3 different stratified sample. So now, okay, let's not do that. I'm sorry. And then the good thing about this is more representative than the random. So for all of our studies, we're going to start using stratified sampling because we want to start um, a good analysis. So if we have random samples of random people or random population, we are not going to have like that like a common and a base characteristic. So we cannot compare apples with pears. So we need to know something that englobes and make people, population, animals on the same page, on the same group. So this is going to be all for the first video. This is going to be a list of reproduction of more than 10 videos, and hope that this will that this help you. This will be helpful for you. Thank you.